Hello, it's Mr. Kingsbury again. Today I'd like to talk to you about some more complex equations and how to solve them. So let's just jump on into this. Make sure you have your paper with you. Let's go. So at this point, you have used Don't Call Me After Midnight several times for several days, and you should be getting pretty familiar with it. It's going to be a lifesaver in this class, and particularly in this unit. As we start to solve more complicated equations, we're going to find that sometimes there's variables on both sides. So that's the new kind of extra thing that we are introducing today. This is why steps 3 and 4 are very important. First, we need to move the terms that have a variable so that they are all on the same side of the equation or of the equal sign. Then we need to either add or subtract the terms that don't have a variable that are still on the same side of the equal sign as the terms with a variable. We do this so that when we're done, all the terms with a variable will be on one side of the equal sign, and all the terms without a variable will be on the other side. And honestly, I realized that the way I just explained that in English probably was not the best and probably didn't make the most sense, but it will as I do some examples. Ultimately, we need to get everything with a variable on one side, everything without a variable on the other, get everything combined so that we end up with one term on one side that has a variable and one term without a variable on the other side. Then we can complete Don't Call Me After Midnight by either multiplying or dividing. Also, keep in mind that there are 3 types of solutions that are possible when solving equations. You can either solve and just get a straight up value for x. You can solve and you discover that there are absolutely no solutions. That's when you get 2 things that are not equal. This is a false statement. And sometimes you solve and discover there's infinite solutions. That's when you solve and you get 2 things that are equal, but neither is a variable, right? This is called a true statement. So let's solve a few of these things so that you get a feel for it, and then we'll call it a day. So let's start with number 1 here. And I'm going to go through all of the parts. Don't Call Me After Midnight. So the first one is distributing. Do we have anything to distribute? Nope, there are no parentheses on either sides. By the way, I put this line here so I can see where the left side is and the right side is. 2, combine like terms. No like terms there. This has a variable, this does not. No like terms here. This has a variable, this does not. Then it says move variables to one side and constants to the other. Now the truth is, you can do this however you want. It doesn't matter which one you start with, just as long as you move everything that has a variable to one side and everything that doesn't have a variable to the other side. I tend to like to move the term that has a variable with the smallest coefficient to the opposite side. That way my coefficient stays positive. So for me, I've got 2 terms with variables, 8x and 7x. I'm going to move 7x because it's smaller. This is adding 7x, so to move it, I will subtract 7x from both sides. Probably you're going to want to see this, so let me scoot this up just a little. And I'm going to zoom in ever so slightly for you, like so. All right, on the left side, 8x minus 7x is 1x, or if you will, just x. You can put the 1 out there if you want. In fact, I'm going to go ahead and put it because I want to make a point here. And then we're going to bring down the minus 2. I'll put my equals. On the right side, 7x minus 7x is 0. That's what we're doing here. We're making 0 pairs. And negative 9 plus 0 is negative 9. So I now have a new equation. 1 times x minus 2 equals negative 9. From here, then we want to move the constants to the other side, right? We just moved the variables to the left. Now we're going to put the constants on the right. So what constants are on the left? That would be this minus 2. So to move it, I will do the opposite of it, which is add 2. On the right side, negative 9 plus 2 is negative 7. On the left side, negative 2 plus 2 is 0, and 1x minus 0 is 1x. Now, technically, according to Don't Call Me After Midnight, we just did 3 and 4. Then we should either do the multiplication or division. This is technically 1 times x equals negative 7. Technically, then we should undo multiplication with division, and you would divide by the coefficient of x, which is 1. On the right, you would get negative 7 divided by 1 is negative 7. On the left, 1 divided by 1 is 1, and 1 times x is x. Now, this is where I'm going to show you a secret that will save you a step. This last step was unnecessary. Please remember that x and 1x are the same. That means then that right here, when I did 8x minus 7x and I got 1x, I didn't really need to put the 1 there. And what's awesome about that then is when I do my adding and subtracting, I end up with x equals negative 7. And since I didn't write down that coefficient of 1, since I recognize that it's understood that there's a 1 there, I don't actually need to do the multiplication, or division, I should say. It's just an extra step. If you can save yourself steps, please do. You will find that mathematicians tend to be very lazy. They're doing things all the time to help save them from work that they just don't want to have to do. That's one of those many things. Let's check out number 2. So, do I have anything to distribute? No. Do I have like terms on the left? Nope. Like terms on the right? Nope. Next, I will put all of the variables on one side and the constants on the other. I have 1a and negative 5a. Again, you can start with any of these that you want. My personal preference is to start with the smallest term with the variable. That would be negative 5a. And to move it, I would add 5a. This is a negative 5a, so I need to put a positive 5a. On the left, 1a plus 5a is 6a. And we bring down the plus 5. On the right, negative 5a plus 5a is 0. 0 plus 5 is 5. Now we'll move the constants to the right. The constant that's on the left that needs to be moved to the right is plus 5. The opposite of that is minus 5. So on the left, 5 minus 5 is 0. 6a plus 0 is 6a. That's on the left. On the right, 5 minus 5 is 0. So I have 6 times a equals 0. I need to undo times, so I will use division. We divide by the coefficient of a, which is 6. 6 divided by 6 is 1. 1 times a is a. 0 divided by 6 is 0. So a equals 0. All right, we're third of the way home. I know you guys are getting excited. No worries. Number 3, 4m minus 4 is less than 4m. Let's start at the top here. Distributive. No parentheses there, so nothing to distribute there. Nothing to distribute there. Collect like terms. No like terms there. No like terms there. So far, we haven't had to do a whole lot with the first 2 steps of Don't Call Me After Midnight. Number 3, move the variables to one side. Aha. I've got variables on the right and the left. Right and the left, right? And then it says move constants to the other. I only have one constant. It's on the left. So let's leave it there and let's move the variables to the right. What needs to be moved to the right? That would be this 4m. It is a positive 4m. I know that because there's no negative sign in front of it. So to move it, I will put a negative 4m. This will be interesting. So 4m minus 4m is 0. 0 minus 4 is negative 4. On the other side, 4m minus 4m is 0. I did not divide or multiply by a negative, so I can bring down the less than, and something very interesting has happened here. All of my variables have been eliminated. There are no m's anymore. So the question I have to ask myself is, self, is this a true statement or not? Is negative 4 less than 0? And that is true. Therefore, there are infinite solutions here. Crazy, right? Yeah. It turns out it doesn't matter what number you put in here. You will always get something smaller on the left than on the right. That was fun. Yeah, I have a weird definition of fun. Number 4. Anything to distribute? No parentheses there. No parentheses there. Any terms to combine? No like terms there. No like terms there. So we need to move the variables to one side and the constants to the other. I have 2 terms with the variable. The smaller one is 5p. It's positive 5p, so I will put a negative 5p underneath it. On the left, 5p minus 5p is 0. 0 minus 14 is negative 14. On the, I hope I said left. That was on the left. On the right, 8p's minus 5p's is 3p's. And then bring down plus 4. So we put all of the variables on the right. Let's put all the constants on the left. The constant that needs to be moved to the left would be this plus 4. The opposite of positive 4 is negative 4. So we will subtract 4 on both sides. On the left, negative 14 minus 4 is not negative 10. Some of you want to do that, and that is not correct. This is a situation where you've borrowed $14 from a friend, and then you borrowed 4 more. Now you owe them $18. On the right, 4 minus 4 is 0. 3p plus 0 is 3p. So we now have the equation negative 18 equals 3 times p. We've completed steps 1 through 4. This was steps 3 and 4 right here. Step 5 says we do either multiplication or division. My variable is being multiplied by 3. To undo multiplication, we do division. We divide by the coefficient of p, the thing it's being multiplied by, which is 3. On the left, negative 18 divided by 3 is negative 6. On the right, 3 divided by 3 is 1. 1 times p is p. So we get negative 6 equals p. And please note, it doesn't matter which side these things are on. As long as one is equal to the other, you're good, right? So I got a equals 0 here. A is on the left. But here I got negative 6 equals p. P is on the right. That's fine. Doesn't matter. You can flip-flop it too if you want. It's not a big deal. I just didn't want you guys to get too comfortable having the variable always on the left. It's usually helpful, and that's usually what mathematicians want us to do, but you need to recognize that sometimes that doesn't happen. Number 5. Do we have anything to distribute? On the left, not so much. On the right, we do! 6 times 1 is 6. 6 times 3k is 18k, and we are adding those. The greater than sign doesn't change, and we bring down the negative 18 and the minus 6k. Then we move the variables to one side and the constants to the other. I'm going to start with the variables. I have 18k and negative 6k. I always like to start with a smaller one, so I'm going to move negative 6k by putting a plus 6k underneath it. Negative 6k plus 6k is 0. Negative 18 minus 0 is negative 18. 18k plus 6k is 24k. And then don't forget to bring down the 6. So we have 6 plus 24k. We moved all the variables to the right. Let's move the constants to the left. The constant that needs to move is 6. It's a positive 6. So we will move it by subtracting 6 from both sides. Negative 18 minus 6 is negative 24. This is like you borrowed $18 and then you borrowed 6 more. Now you owe that person $24. On the right side, 6 minus 6 is 0. 0 plus 24k is 24k. And we neither multiplied nor divided by a negative, so we can keep the greater than sign. So our new inequality is negative 24 is greater than 24k. Now we need to undo multiplication, because remember, this is 24 times k. So to undo multiplication, this is step 5. We use division. We will divide by 24. Always divide by the coefficient of the variable, in this case 24. On the left, negative 24 divided by 24 is negative 1. On the right, 24 divided by 24 is 1. 1 times k is k. We did divide, but we did not divide by a negative. So this is greater than. So we get negative 1 is greater than k. All right, one more problem, and then I'm done. Let's start with distribute. Do we have anything to distribute on the left? We do. 2 times 4x is 8x. 2 times negative 3 is negative 6. We also have negative 8. Less than or equal to. And then do we have anything to distribute on the right? Nope. No parentheses, so nothing to distribute. Step 2, do we have any like terms to combine? On the left, we do. Negative 6 and negative 8. You put those together, you get negative 14. And we'll bring down the 8x since there isn't anything to combine with on that side. We'll put our less than or equal to. On the right side, do we have any common like terms, rather, things that we can put together? Unfortunately, no. So we will just rewrite 4 plus 2x. Now we will put all the variables on one side. I've got 2 terms with variables, 8x and 2x. Again, I'm going to go to the smaller one, which is 2x. It is positive 2x, so I will cancel it with a negative 2x. On the left, 8x minus 2x is 6x, and we'll bring down the negative 14. On the right, 2x minus 2x is 0. 4 plus 0 is 4. So we get 6x minus 14 is less than or equal to 4. Now we'll move the constants to the right. We will do that by adding 14 to both sides. On the left, negative 14 plus 14 is 0. 6x minus 0 is 6 times x. On the right, 4 plus 14 is 18. And we did not divide or multiply by a negative, so I'll just bring down the less than or equal to sign. Last step is to divide or multiply. We've got 6 times x is less than or equal to 18, so we need to undo this times. You undo multiplication with division. We will divide by the coefficient of x, which is 6. 18 divided by 6 is 3. 6 divided by 6 is 1. 1 times x is x. So x is less than or equal to negative 3. And that is how you solve inequalities and equations with variables on both sides. Thanks for tuning in. Appreciate you taking notes, and I'll see you in class. Bye.